Hello everyone, this is us again, Embry Prescott's Rapid Prototyping Lab. Here today I am with one of our very knowledgeable technicians, Mr. Nicholas, and he's going to tell you about the topic that I know you're not going to find everywhere easily, and that is called actual 3D printing or 3-axis 3D printing, as opposed to what you have been doing called 2.5-axis 3D printing. So without further ado, I'll pass it all to Nicholas and he'll take over. So class is yours.
All right, thank you. As he said, I'm Nicholas. I've been a technician in the RP lab for 3 years now. And I've worked a little bit with this 3-axis 3D printing a little bit, so I'm going to tell you a little bit more about that. And so probably wondering, like, what is 3-axis 3D printing? Isn't 3D printing already 3D? And the way 3D printers work currently is 2.5-axis, which means at any one time it's only operating in 2 axes. So it only prints out in single layers, and then it steps up, does another layer. In full 3-axis 3D printing, it's actually able to combine all 3 axes at the same time to print more like this, where it has some planar base layers, but then it goes over that in full 3D motion. And so obviously that's got some benefits in certain areas, especially with like airfoils. On a piece like this, you can see visible layer lines in here, and that kind of creates a rough surface. With actual 3D printing, you can have the entire top surface as a single layer, and so it becomes a lot smoother. Now obviously there are some hardware limitations to this. Obviously you've got to have a printer that's got good axis movement, but then the hot end actually becomes very important, because a lot of printers have this very large heatsink and fan right above the nozzle, and on some printers that's even as close as down there. And obviously if you're wanting to get down into valleys or something on a surface, like if this was your part line here, you're limited to only being able to go as deep as you can go before you hit the actual printer. And so you actually have to kind of redesign the printer a little bit to get as much angle out of here as you can, so that you can actually get down into the valleys. And we can see that on this ender here that we've modified. Originally an Ender V2, which had very little clearance, but we've modified it here where we've rebuilt the entire cooling assembly to kind of come in from the sides, and you can see we have a much deeper angle than a typical Ender V2, which is much more flat down here. And so that's more suited to getting into the valleys and stuff of an actual 3D part. So aside from the hardware, you're probably wondering, how do I actually get the printer to do that? If I use Cura or Prusa Slicer or anything like that, it doesn't have that kind of option. The answer is actually an experimental version of Slicer developed by a master's student to actually do this non-planar printing. And currently it only runs in Linux, and it's fairly experimental, but I'll go ahead and show that to you now. If we turn over here to the screen, we can see I've got Slicer here. I've got this part here that's definitely got the deep valleys and whatnot. And so we go into print settings, and there's this new feature here that's been added that doesn't exist in regular Slicer, and it's called Non-Planar layers. And you have the ability to turn it on and off and change all these different settings about how the printer can actually get into valleys. So we'll go ahead and turn it off for now, and we'll slice this part. So go to preview. And you can see it looks like any standard 3D part, where you've got the very visible layer lines, and it's all smoothed out and all planar, just like that. Now if we go back into print settings and we turn on non-planar settings, you see all these settings on gray, and so these are just all different angles that really define the geometry of the hot end and where it can reach. So, and they all have little help menus, or most of them do, that help kind of point out what they do. And so these just kind of say what kind of angles can I get into, which is largely dependent on the nozzle shape, and then also the width of your hot end cooling, and then also kind of the depth, because there's definitely limitations, like where even if you can go shallow for somewhat deep, or you can go really steep angles but not as deep. So that's kind of just defining that geometry here. And so if we go back to here and then we hit the preview again to slice it, you'll see it takes a lot longer because it's a lot more computationally demanding. And you can see here our top surface now, all those layer lines are gone, and it's all one smooth layer. And that's really what you're looking at in the non-planar here. You can see it's a little glitchy. It's still experimental, and so it's still missing some optimization. But if we drag down our preview, you can still see that it starts off like any other print, and only in the last couple layers does it switch over to non-planar. And that's just to create that good stop smooth surface, but you still have to have a base to put it on. You obviously can't start 3D printing right off from the ground, or you'll just kind of be doing the spaghetti mess. So yeah, you can see that there. And then there's all different kind of settings you can play around with on this. Alright, so let's take a quick look back at the print settings here and kind of go over these settings in a little more detail, just so you guys know what they actually are. So this maximum non-planar angle has to do with the geometry of the part you're trying to print. You guys see this here? So if you've got a print kind of like our test piece that kind of comes along and goes down into a valley before coming back up, this maximum non-planar angle is the angle on the surface of your part. And it just says what angle will it actually try to go down into. Right beneath it is the non-planar collision angle, and that has more to do with the geometry of your nozzle, and it says pretty much at this angle, if the part is at that angle, trying to print at that, it will collide with some part of the printer. So it won't try to print anything there. And I don't remember entirely, but I do believe that those angles are measured off of the vertical axis. Okay. And then our non-planar area here, that's just kind of how small of a surface area to avoid. So like if you have just a small divot here, and I've currently got it set to 2 millimeters, say that the surface area of this divot was less than 2 millimeters, it would just avoid that area and it would just print at regular 2.5D. The maximum non-planar collision height is actually this height kind of here. Again, it's the geometry of your printer and a little bit of the geometry of this. So if you have something with like a really big divot that goes beyond that height, it won't try to print there because it would end up bottoming out your printer, and obviously you don't want that. And then ignore collision size is just another geometrical constraint here. And so this version of Slicer that I'm using comes from a GitHub page. Let's see where it is. Right here. So we are using the ZipMat branch of Slicer. This is where they have added in these non-planar settings and all this functionality. So if you want to try it out yourself, there's a fair amount of documentation here on how to get it up and running. It does have to run in Linux, as I said earlier. So if you have a Linux system, or if you have a virtual machine that can run Linux, it's worth just going to this GitHub page and downloading it and seeing if you can try to get it to work. Alright, so there's a little more detail into what this actually looks like. We have a video here of it actually in action. So let's just go ahead and let that play. Now you can see how it's moving back and forth in the XY plane, but it's also going up and down along the Z axis to match the valleys of this part. Okay. And then so that part actually ended up looking like this. So you can kind of see how it flows up and down in those valleys rather than having all those stepped layer lines. And so that's really what this non-planar is for, just to get that smooth top surface and get rid of those layer lines.
So one question, what is really the main limitation of this that you think the 3D printing companies have not adapted it yet? Is it just because of the narrow valleys that you cannot print, or what? What is the main limitation?
I would say from my experience with it, the main limitation would definitely be the hardware side of it and just trying to get your extruder into those valleys and stuff. Definitely limits where you can get. Kind of have to specially design it to get a lot of geometry.
Okay. And so this is like general code. So you applied it to the Ender Creality, but if you want, you could do it with Prusa as well, as long as the size of the head allows it, really, right?
Yep.
Because you modified clearly the size of the head for Ender, right? Do you think the size of the Prusa head is also quite big for it?
Yeah, I think as default, the Prusas probably won't be able to pull this off just because the nozzle barely protrudes from the bottom of the cooling fans.
I see.
So you'd have very, very shallow valleys that you'd be able to get into without modification. If you rebuilt the hot end to have the nozzle stick out a lot further, they could definitely pull off some non-planar.
Use like some tall nozzle or something.
Yep.
And also maybe kind of cuts through the sides of the head and make it kind of like something very narrow and tall, right?
Yep.
That's the kind of thing.
Yeah.
But ideally, you should be able to apply it to any printer as long as you get the hardware done. And as you all saw in the software, there are settings for that, right?
Yep.
So as long as the angles are not basically more than something, or the area that you're printing is not less than something, you're allowing for it to do non-planar. But as it turns out, it's really just you need to download the software that is written by the master student in Germany and get it to go. Now, the last question, surface quality-wise, you saw some good improvements, right?
Yeah.
Especially the stepping problem, those step kind of thing.
Yep. So yeah, if we can get a good view on this, you can see how the steps go away. But there's also a little bit of issue with how it currently works, is there's kind of a layer separation here where it transitions from the planar to the non-planar printing. And that might be due to the geometry or still just how the software is working right now. Since it is still experimental, not all of the bugs have been worked out of it.
Okay, is there anything else you want to share with us, or you think that's good for the intro?
I think that's a good overview of what non-planar is, and maybe a good way to start looking into it if you have that interest.
Okay, perfect. So thank you so much, Nicholas. Appreciate it. This is what we call actual or contour 3D printing. And really, we are directly using the code by the master students he mentioned in a university in Germany. But if you look at his master's dissertation, I'm sure you can find all the details about how he exactly coded it and everything, right? Just modified the G code. And hopefully you can come up with improvements. Hopefully you can apply that to your own printer and benefit from this 3-axis printing versus 2.5. Thank you so much. Thank you. And I will see you in my next video.